All right, lesson 3.2a, investigating rates of change. A rate of change is the ratio of the amount of change in the output to the amount of change in the input. A rate of change in a table. So we're going to look at a table. Eve keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or variable. All right, so we have number of lawns and the amount earned. So our first day she mowed one lawn and she earned $15. So that's how I'm going to set it up to find out my rate of change. How many lawns and then how much she earned. One goes into one time. Bring down my 5. 1 goes into 5 times. Rate of change for day 2, 3 divided by 45. 3 goes into 4 once. 4 minus 3 is 1. Bring down my 5. And 3 goes into 15 5 times. Day 3. She mowed 6 lawns for $90. 6 goes into 9 once. 9 minus 6 is 3. I'm going to bring down my 0. 6 goes into 30 5 times. I'm seeing a pattern here. I hope you guys are too. Day 4, she mowed 8 lawns. I'm sorry, 8 lawns? Seriously? In one day? I could not mow 8 of my lawns in one day. That would just be too much. It takes me hours and hours to do it. Anyway, 8 goes into 12. Well, first of all, we know 8 does not go into 1, so we have to go 8 into 12 once. 12 minus 8 is 4. We're going to bring down our 0. 40. 8 goes into 40 5 times. And it's even, just so you know. All right, so our last one, I'm going to move this out of the way so it doesn't get in the way when I'm writing. 9 divided by 135. 9 goes into 1 0 times. 9 goes into 13 once. You know what? I need to move this so I have space to write my answer. Once. 13 minus 9 is 4. Bring down my 5. 9 goes into 45 5 times. And it's even because 5 times 9 is 45. All right. So we know our rates of change for each day. And if you notice, they are all the same. So our next step is to determine if the rates of change are constant or variable. I would say that they're constant because that means that they haven't changed. So, constant. Nice. All right. I'm going to clear this one and we're going to go to the next page. Does that make you guys dizzy watching it on the screen? I need to know because it kind of would make me dizzy. I'm trying not to do it fast, but. All right. Rate of change in a graph. The graph shows the distance that Nathan bicycled over time. What is Nathan's rate of change? I'm going to move this down just a tiny bit more. And let's see where all of our numbers on the graph are because they didn't give us any numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's our time. So our time, 3, 6, 9, 11, 12. And you know what? I'm going to put my 15 down here just because I can. Distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I just want to make sure that I got that right. Okay, because sometimes it's easy to lose track of where you're at on there. All right. So my distance, my first one's at 3. My second one is 5. My third one is 7. Fourth is 9. 11. And 13. So to find the rate of change for each day, I take my first day and I do 3 divided by 3, which gets me 1. Day 2, or distance 2 that's plotted, is going to be 6 divided by 5. We know that that does not actually go in evenly, so I'm going to add a 0. And 6 goes into 50. How many times? Let's see. Okay, so 6 into 50, once again. Let's see. It's not even, but I am going to say 8. So that gives me 48. And that is going to give me a 2. So I'm going to leave it at 0.8. I'm not going to take it out any further. My next one is going to be 9 into 7. I'm going to add a decimal and a 0. 9 goes into 70, not evenly, but 9 times 7 is 63. And then this will be 7, but I'm not going to keep factoring it out. Once again, I just need 1 decimal point for now. And my next one is going to be 11 into 9. Doesn't go evenly, so I'm going to add a 0. And 8 times 11 is 88, which gives me 2. And let's see, I'm going to do my 12 up here, if that's okay. 12 into 11. Once again, adding a decimal. Complicated math going on here, but you guys are totally up for this challenge. All right, 9 times 12 is going to be 108. So our answers here seem to be changing, which means that he is riding at a variable speed, which makes sense because if you're riding a bicycle, unless you're riding and it's totally flat, you're going to change speeds periodically. Awesome. So let's clear this and see what else is on our page here. Oh, see, we got to try this. The table shows the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. Well, we can do this quite simply, right? Well, if my pen's on, we can. So we do our 0.5 5 goes into 13 twice, which gives me 10. 3. I'm going to put a decimal here. Bring it down. Bring down my little 0. 5 goes into 36 times. Okay? So that's that rate. And my next one is 1.5 into 31. So this is actually a 15. 15 goes into 30 twice evenly, which leaves me 1 and a 0 that I have to bring down. Wow, this one is going to keep going. So 2.0, and I'm going to stop there because I'm going to show you it's already different. But we're going to do the next one just to be sure, okay? We have our 2 into 26. 2 goes into 2 once. Bring down our 6. 3 goes into 2 goes into 6 3 times. So now it went to 13. That's pretty crazy because now it's gaining speed. Or the height. That's crazy. Anyway, we know it's variable because we have 13, 2, and 2.6. So the approximate height of a football after it is kicked changes at a variable speed. And if you notice, we didn't even have to get to our last set because we could already prove with 3 separate processes that it was different. So I did 3 equations instead of having to do all 4 and verified that it was variable. Got it good? All right, I'll talk to you guys later.